Okay, so distance, we're going to do the distance between 2 points. So if you had just a plain old horizontal number line, it's actually not too bad. So let's say I had the point -7, and I'll graph it here. Ooh, board's a little off. And let's say I had the point, I don't know, 3. Okay, so -7 and 3, you could just count them. Each of these marks could represent a foot. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 feet between the two. If this number line, each mark represented 1 foot. Or you could just simply subtract them. So -7 minus 3, and then you take the absolute value of that, because we're not concerned about direction, we just want distance. So the distance of that would be -10, the absolute value of -10, which would be 10. And it doesn't matter what order you subtract it. You could have also subtracted it 3 minus a -7 and took the absolute value. When you do that, you got plus a positive, so it's again 10, and the absolute value of 10 is 10. So the distance between those 2 points on that number line is 10. Where it gets complicated is when we come up with this is called a Cartesian coordinate system. You've got an x-axis and a y-axis, so we basically take two number lines and put them together, so we have a coordinate system to plot in 2 dimensions. And so I give you a point here, a couple points. Point A, -3, 4. And so that would be to the left 3 from the origin. Here's the origin. 1, 2, 3, and up 4. 1, 2, 3, 4. And so we'll call that point A. And then 7, -2 would be to the right 7. So 1, 2, 3, 4, 5, 6, 7. And down 2 would be that point right there. So we want the distance, and I'll call that B, between these 2 points. Well, when they're at an angle like that, you can't just count diagonals, because they're all a little different. Notice here, this one right here is longer than this little piece here, and so you can't just count 1, 2, 3 like you did on the number line. So you got to come up with something else, because the horizontal distance and vertical distance are different than the diagonal distance. I'm having a hard time drawing a line today. But anyway, so back in geometry, when you took the geometry class, hopefully you've had that. If you haven't, I guess this will be something new for you. We did something called Pythagorean Theorem, where we came up with a right triangle, which I'll draw in there. And we know then the horizontal and vertical distances, there's a right angle. And we know this horizontal distance is 10, and this vertical distance is 6, I do believe. So 1, 2, 3, 4, 5, 6, yep, and 10. And so what we're going to do here is use this Pythagorean theorem to figure that out. Well, that's a squared plus b squared equals c squared. And if you think about that, then the 2 legs represent 10 squared plus 6 squared equals c squared, and c is the hypotenuse. Doesn't matter. C has always got to be your hypotenuse. A and B are your legs, distances. And so now you just go ahead and simplify that, and that would be 100 plus 36 equals c squared. And so c squared is equal to 136. You root both sides to get rid of the square, and c is equal to the square root of 136, which I think can be broken down for, I think in 34, yeah. And 2 and 17, let's go down a little bit here so I got some room. And 2 and 2. Well, there's a pair. I don't know if you've done these before, but how to simplify a radical. So that would be 2 root 34, because those don't pair up. So I'm hoping that you've seen these before. If you haven't, look them up. Simplifying radicals, that works pretty good. Or you could also just take the square root of 136, which this is a near rational number, so it would be approximately equal to 11.66. So it's almost 12 units long from A to B. In college, you're probably, in a college algebra course, they're probably wanting this answer the exact answer. So that way you can round it however you want it rounded at any point. Now, it gets kind of cumbersome to draw out this triangle every time and use Pythagorean Theorem every time. And so what's really happening over here is I'm creating a formula. A in this case, and I see I labeled them differently, but it doesn't matter between A and B. So A in this case, I called it 10. So I'll take that out of there. So here's 10. And notice all it is. It's the difference of my x values. So I took 7 minus a negative 3, which is 10. And then for my b, which is here, the 6, I took a negative 2 minus a 4, which is negative 6, and the absolute value of that is just 6. We just want the distance. And then we squared those distances, added them together, and then took the square root. So you can derive a formula from that called the distance formula. And then you wouldn't have to graph these at all. And in fact, it works better because most numbers aren't very nice, like what I just gave you. And so the distance formula looks something like this. The square root of your second x minus your first x squared plus your second y minus your first y squared. And so if you had just any 2 points, let's say I had 6, negative 2, and 3, 4. All right? So if you call this your first point, and this your second point, it doesn't matter which is which as long as you keep them consistent, you can plug that into the formula then. This is x1, this is y1, x1, y1. This is x2, this is y2. Oh, so y2. So when you do this, the distance then would equal to the square root of 4, oops, sorry, I was doing my y first. I'll follow the formula I have up above there. So 3 minus 6, doesn't matter if you do x or y first, squared, plus, now I can do it, 4 minus a negative 2 quantity squared. And so your distance in this case is equal to the square root of negative 3 squared plus, plus a positive there for 6. So that would be 6 squared. And you always follow your order of operation. Don't square root this stuff right away. Because, and say, well, the answer is 3 plus 6. No, that doesn't work. So you got to keep going. So negative 3 squared is positive 9. 6 is 36. Keep working your way down. Do this for you. Excuse me. Is 45. And then, square root of 45 then is the answer. Well, again, it's good to be able to simplify your radicals. So that's this different. 45 breaks into 9 and 5, 3 and 3. So your answer is 3 root 5. If you think about it, the square root of 9 is 3. 5 doesn't have a square root, so it stays inside. So it's 3 root 5, or, square root of 45, if you think about it, square root of 36 is 6, square root of 49 is 7, so it's about 7. It's somewhere in there. And so that's the distance formula. You're going to want to use this when you have points that get ugly. Let's say you had things that are hard to plot, by hand. Let's say you had square root of 2 comma square root of 12 and 6 comma square root of 3. And you had to find the distance between those. Well, it'd be tough to plot those on a graph. You could do it. You'd have a lot of estimation. But if you want the exact answer, the only way to get to that is the distance formula. So I'm not going to do that one. Well, it's 9 minutes. Stop the video if you don't want to watch anymore. I would completely understand. But how I would set this up, distance equals your x2, 6 minus the square root of 2 squared plus square root of 3 minus the square root of 12 squared And I'm just going to roll through this quick because I don't want to use up a whole lot of video, but this gets kind of complicated, as you can see. And there's no real shortcuts to it. You're going to have to, this is a binomial that you're going to have to write out twice and use the distribution property to figure it out. Square root of 3 minus, now square root of 12, I'm going to break that down. So that's 2 root 3. I just know that because I've done it a million times. So minus 2 square root 3. And you're going to do some fancy algebra that hopefully you've seen before. None of this, I hope, is new to you. This is a very difficult problem. 36, and I can't guarantee, since I'm doing it fast, that I'll probably screw it up. Plus 2 plus 3. I'm doing first, outer, inner, last, if you remember FOIL, but 3 minus 2 times 3 is 6, minus 2 times 3 is 6, plus 4 root 9, which is 4 times 3 is 12. Wow, that was crazy. I guess all that's under the square root. And so you're left with, you can kind of combine what you have, and hopefully I haven't made an error. It's possible I did, because I didn't check I didn't do this problem ahead of time. So 36, 37, 38, 39, 40, 41. You could add that one next, and these two actually would cross out, so you'd have 41. So you got 41 minus 12 square root of 2, and then the square root of that. So that is a very nasty looking number, and that's the distance between the two. So now you'd have to get your calculator out and find that distance. I'm not going to take it any further than that, because that just shows you that's beyond what we'd need to do on any distance formula until you get into something really advanced. So best of luck to you. Hopefully that problem didn't scare you. Go back to the original one if that one looked ugly to you. See you next time.